what is the motivation for integration by parts? That's our goal today. Is I want to show you how we arrived at the formula that we use for integration by parts. Okay, so the first thing we do is we look at the product rule. So do we remember the product rule for derivatives? It says that if you have two functions, say you have two functions f of x and g of x, and they're both differentiable, then the derivative of the product is equal to, what's going to be the derivative of f times g of x plus the derivative of g times f of x. Okay, so that's our product rule, right? It's just saying that f prime g plus g f prime. I'm actually going to write over here the same, but we just are using different notations so that we're not keeping track of the x, the independent variable. Okay, now the next thing we want to do is we want to use the notation for indefinite integrals. So remember that here's what that means. What that means is if we know the derivative of f times g, then the integral of the derivative of f times g is equal to, so I'm going to do it like this, is equal to f times g, right? Because that's what this notation means. It means whose derivative is the integrand. And if the integrand is already a derivative, then the operations are canceling each other out. So this is the idea of what we're doing. I'm going to write it with notation that we're used to, using the f of x and the g of x. Okay, so the first thing we do is we say since the derivative, right, so since f of x, g of x prime is equal to f prime of x, g of x plus f of x, g prime of x, it must be that f of x, g of x is equal to the integral of all of this up here, right? So in fact, I can just kind of lasso that. So here we go. Dx. Okay. And we can actually rewrite this by using our properties of integrals. So say I've got the integral of f prime of x, g of x, dx, plus the integral of f of x, g prime of x, dx. Okay, and all this is equal to f of x, g of x. And so the last thing that we would need to do in order to get our formula is to rearrange So look what we have right here. If we rearrange this, then this part, see, that's our u. Back here's our dv. Right? And then this is u and v. And what we have here is the integral. Now the g is going to be v, and the f prime dx is actually du. So we can rewrite this as du. So if we rearrange, then we would have that the integral of u dv is equal to uv minus the integral of v du. And what did I do? I just subtracted, right? So I just subtracted the integral of v du from both sides. Okay, so then that cancels out with that. And that's what we're left with. So the main idea is if we have an integral if we have an integral that we're trying to evaluate, and it looks like this, is actually the integrand is u times dv, then it might be beneficial for us to rewrite our integral like the left-hand side. Okay. Now this only makes sense if we actually can evaluate this integral of v to u. Okay. All right. Thank you.